Now I want to talk about function notation. Function notation is just a special notation we can use to indicate that something is a function. You don't even have to think about it. You don't have to wonder about it. We guarantee you it's a function. And all we do in function notation is we replace the y variable with f parentheses of x. Instead f of x, you can also name them other things. You can name them g of x or h of x or k of x. So they can have different names. This notation provides a way of denoting the value of y, the dependent variable, that corresponds to some input number of x, the independent variable. So that's function notation. Here's where we use it. If I give you the function g of x equals 3x squared plus x minus 4, that's really the same thing as y equals 3x squared plus x minus 4. But if I ask you to find g of negative 3, what am I really asking you to find?
X equals negative.
I'm asking you to find what y value pairs where x is negative 3. Yeah. I'm asking you to substitute negative 3 in the spot for x and tell me what it equals. So I give you the independent variable, and you were supposed to tell me what the dependent variable equals for that value. So it's just a substitution process. So next, we're going to say g of negative 3 is what I get when I replace x with negative 3. So I'll keep the 3, I'll take the x, and I'll put parentheses negative 3 there. And keep everything else the same. Then you clean that up. We get 3 times 9 is 27, minus 3 minus 4, for a total of 20. 20, yeah. So we say that g of negative 3 is 20. And guys, what that means, and I think a lot of people don't really understand, but what that means is that the ordered pair negative 3 comma 20 is on that parabola. It's a quick way of asking you to find one of the ordered pairs. If x is negative 3, what's the y value? 20. That's how you find it. So you guys try the next one. Now I would like you to find g of k. So that just means that I'm going to replace every x with a k and see what I get. So it's weird, but we're going to do it. G of k. What's it equal?
3k squared.
3k squared
Plus k
plus k minus
minus 4.
4. That's all. Every x is just replaced with a k. Now it didn't become a numerical value because I didn't substitute in a number. I substituted in another variable. So my answer is also a variable. Now this one's a little trickier, part C, where we're substituting negative t cubed. Negative t cubed in the place of your x's. So we know that we're going to have 3 times, and instead of x, I'm going to put negative t cubed squared plus, instead of x, negative t cubed minus 4. Now I want you guys to take a second and try to get rid of those parentheses and see what happens when you do. To get rid of the first parenthesis, that gives us 3 times t to the 6th. A negative squared is a positive, and a t cubed squared is a t to the 6th. So we have 3t to the 6th plus negative t cubed, which is just minus t cubed, minus 4. So our final answer is 3t to the 6th minus t cubed minus 4. That is what we get when we find g of negative t cubed. For the final example here, we would like to find g of k plus 1. G of k plus 1 means that everywhere I see an x in my original problem, I should replace it with what? Parentheses k plus 1. So instead of x squared, I have k plus 1 squared. And instead of plain x, I have k plus 1. And then we bring down the minus 4. You have to distribute out all of those parentheses and combine your like terms. Take a moment to try to do that on your own. First thing you need to do is you need to distribute the parentheses. So we have 3, and k plus 1 squared is k squared plus 2k plus 1. Now this right here isn't to a power, and there's nothing to distribute, so I can go ahead and drop those parentheses. And once we square double square, we have to distribute the 3. So we have 3k squared plus 6k plus 3 plus 1k, and then these two I'm going to go ahead and combine to make minus 3. What does that give you grand total? 3k squared plus 7k. And what happens to the positive 3 and the negative 3? They cancel to 0. So when you clean all of that up, you end up just getting 3k squared plus 7k. And that's just a quick introduction to function notation, how we use it, and how we simplify from there. The reason we talk about it at this point is there's a pre-calculus topic called the difference quotient. That's what's coming up next. And in order to understand the difference quotient, you have to understand function notation really, really well. And all function notation is a substitution process, where you substitute something in the spot of your variable and then you clean it up. Let's go ahead and look at the difference quotient. The difference quotient is a fraction built upon different types of function notation. It's the same fraction every time. The difference quotient is always given by f of x plus h minus f of x divided by h. That is your difference quotient every time. And we use it a lot in calculus. So it's really important that you kind of understand it before you get there, because we assume that you can work with function notation really, really well at that point. It's basically used to find quantities such as the velocity of a guided missile or the rate of change of a company's profit. So it is a way to talk about slope for nonlinear things, which is kind of probably weird for you to think about. But that's what the difference quotient is. So let's talk it one more time. It is f of x plus h. That's one substitution. You go and you find that. You find f of x plus h. And you clean it all up. The second step is you subtract f of x. What is f of x?
Y.
It's whatever your y is, whatever y equals to start with, which we basically say is your original function. And then finally, you divide by h. At that point, you should be able to factor and cancel an h. Once you factor and cancel an h, you're finished. That's how the difference quotient needs to go each and every time you do it. So you have to kind of think of it as those 4 steps. Let's find the difference quotient for 1x squared minus 2x minus 5. That's our function. F of x equals that. That's a parabola. So we're going to find the difference quotient for that parabola. Start with the formula. The difference quotient always equals f of x plus h minus the original function, whatever f of x was to start with, divided by h. And we know that there are several things that we have to do to get through that. We're just going to start with f of x plus h. That's where we have to start every time. So that means we take the original function, we take the x's out, and what do we put in their place?
X plus
Parentheses x plus h. So we take the original function, x squared minus 2x minus 5, remove the x's, and in their place, put a parentheses x plus h. That's always your step 1. That is f of x plus h. Any questions about how I got that? It's going to be your first step every time with the difference quotient. You're going to take the original function. You're going to take the x's out. In their spot, you're going to leave a parentheses. And in that parenthesis, you're going to put x plus h. Then make a big subtraction sign. open a huge parenthesis there, and put the entire original function there. It's really important that you make a parenthesis there. You can't see it in the formula, but you do need to insert your own parenthesis right here. So make sure you always put a parenthesis there. That's your original function being subtracted off. And finally, you divide the whole thing by h. That's how you set it up. That's just the basic setup of the difference quotient. From there, you're going to distribute out all of your parentheses and your minuses. Then you're going to factor an h. Then you're going to cancel an h. And then you will be finished. So after this, it's just playing around with the algebra, cleaning it all up. But this is the hard part, is getting it set up. Usually once people get it set up, they can go from there. So let's start distributing. I have to square double square x plus h. That gives me x squared plus 2xh plus h squared. Any questions about how I got rid of that first parenthesis? Then I have to distribute minus 2. So I have minus 2x minus 2h minus 5. Next, I have to distribute the minus sign in front of this big parenthesis. So we have minus x squared plus 2x plus 5. All divided by h. So it looks really ugly in the middle. Things start to look really, really bad. But now stuff will start to cancel. Anything that does not have an h should cancel. Let's look. I have a positive x squared here and a negative x squared. So those cancel. I have these have an h. This one doesn't. Negative 2x cancels with positive 2x. Anything that doesn't have an h should cancel in this step. After you've distributed, you should combine your like terms, and anything without an h should cancel. If it doesn't, you've done something wrong. Finally, this negative 5 and positive 5 cancel. Everything left should have an h in it. Let's see. We have a 2xh plus h squared minus 2h all divided by h. Do you see how every single thing that's left has an h in it? And that will allow you to factor an h out of the top. Always just factor an h, nothing else. 2x plus h minus 2 all over h. And once you factor, the h on top and the h on bottom should cancel to 1. And your final answer is what is left in that parenthesis, 2x plus h minus 2. So we say that the difference quotient of x squared minus 2x minus 5 is equal to 2x plus h minus 2. It is a long process. It takes a while. The only way to do it is to practice it and to get good at it. And you can Google, if this isn't enough for you, the examples we do in class, you can Google this and you can find it being worked over and over again on the internet. So it's a great time to kind of Google, look for other videos. You can do the watch it video on WebAssign, but you are going to need to practice this a lot.